So, hi, my name is Victor. I am a biomedical scientist by training, and I also have medical device startup in Germany. But our project PolyVent is a volunteering initiative to create an accessible design for ICU ventilator. So what is a ventilator? Ventilator is a machine with the power of life and death. This is a machine that is going to provide breathing for patient when he's no longer capable of doing them themselves. Naturally, when the pandemic hit, these machines have run out of supply very quickly. They are very hard to scale in production, and they're prone to supply chain bottlenecks, which resulted in the shortages in the hospitals around the world, including wealthy countries including Italy, especially the United States. Shortage of ventilators is a situation which, you imagine that you have 10 patients and you are the clinician that has to choose which one of them get delivered to die because you only have enough machines for some of them. So this kind of practice has happened even in, like, for example, Italy. And this is completely normal occurrence for places where this, like I said, is a luxury. And that's what we're trying to solve. We're trying to make it as accessible as possible. So the idea for PolyVent is to create a design which in wealthier countries can be used during pandemics. But for countries which are not, do not have other options anyway, this could become just an normal standard of care ventilator.
So me and Victor, we've been working on the whole ventilator project right from the beginning, like we actually started. So I think right as in the lockdown started in March for Canada, and I think within a few days I joined a Facebook group, and then the Facebook group mentioned us to another competition, and that competition had a platform where we could make teams and we could meet other people, and we actually started our first team there where we participated and collaborated, and that's where me, Victor, and Nathaniel and the base group actually met. A few weeks ago he just called me and said we've managed to get some funding and some resources and we can actually go on to another prototype. And so that's what brought us to Linz. So
I came here from the Netherlands, so actually most of the parts that you see here I took here from the Netherlands in my car, so that was quite a drive. I started working on ventilators also around the middle of March, when the news was really grave at that time.
Yeah, just for the record, we're all volunteers and we have our own businesses, our own things. So.
As Victor just said, ventilators are used to breathe for patients who are unable to do that on their own. And so what this device does is it takes in air and pure oxygen, mixes those, and then delivers that to the patient's lungs. So side by side here we have two towers, the two pump modules. And by spinning these motors at the top, these bellows here will be pushed up and down. So when the bellows are pushed down, the air is delivered to the patient, and when they are being pulled up, they will suck in both air and oxygen, ready for the next breath. Now, one of the things that we've really focused on during the design is to ensure the adaptability of the design. For example, if you have different motors available in your country or in your area, you can adapt these brackets and you can mount the motors that you have available. The same thing goes for the bellows. If you have different diameters, different heights, you can also adjust this and make that compatible. And the final thing, in this particular version we are using solenoid valves to route the gas to the right places at the right time. But what you could also use is a pinch valve like this one, which in some cases will be easier to produce as well. So with that, I would like to now pass on to Austin, who will tell you about the materials that go into this case.
a lot of the parts on this, the big problems are that there's not really that many ways to make the parts, especially for some of the more costly ventilators, because a lot of the parts are like 100 different pieces that need to have extremely high tolerances and need to be crazy machines to make them, and which really slows down the capacity that you can produce them. So we've just tried to make things around it as generic and as simple as possible. So we have plastic pieces here which are useful in certain circumstances where it's going to be a short-term ventilator for countries that are going to be buying these for the pandemic, are going to be disposable essentially, where you only need a few months of use at a time. And then we have ones for countries that are looking at these for more long-term options where you can actually CNC these out of metal. Both of these are pretty standard manufacturing methods, but they both offer huge differences in terms of what it makes the ventilator capable of and what the ventilator can do. So that's something that is probably one of the bigger features of this design and this whole team, is that we're not creating, not every single part needs to be manufactured to a tolerance of a tenth of a millimeter. So, and we can really speed up production and make the accessibility way more available.
Correct. There is a lot of 3D printing going on, mostly for the structures here. There is also just a simple metal work that Austin has been doing a lot of, which is downstairs, which is just cutting the tubes, cutting the plates. There's going to be some laser cutting for the decals up front. And we've also used the SLA printers there in the corner to 3D print these bellows, which is quite extraordinary, I would say. So Datron kindly helped us to CNC out this part, plus a few other parts that go into the top part of this pump module. And we are very grateful for that.
Grand Garage has been great for all of the different the tools, and 3D printing has been one of the biggest things that we use. They have the printers here are really high quality, and you can get some really nice looking parts. All the printed parts here look extremely professional and have a really nice finish to them. So like all this is printed. All the corner brackets holding the metal together printed. The outside finishes with the handles, and it's all printed. So the printers here are capable of creating some pretty nice stuff, and that's been greatly, super useful to us. The tools and all the materials that Grand Garage makes accessible are hugely useful and make us possible to do this. But really the biggest factor for the prototyping help is having the people and the resources here who can explain to you how to do certain parts better or how to use the machine this way. Especially with the CNCing, having the professionals here at the Grand Garage it's exactly what you need to be able to do these sorts of things quickly and effectively, because it just wouldn't be possible in a home garage or a home workshop without having some of the expertise that Grand Garage can offer to be able to make these sorts of things possible.
I can certainly speak to that. For Air-to-Wall, I had of course a lot of help online from the rest of the Air-to-Wall community, but at the same time, purely physically speaking, I was alone at my home. And that just limits you in a lot of respects with what you can do. So being together here is a really huge help, and I think it's very much visible in the final product, being quite substantially better than the prototype I built before.
So all the brain power still needs a facility to implement, to build the first proof of concept of the idea. And that is where I think the Grand Garage has done great here. So.